Hello and welcome. Thank you for joining us for today's Ask the Pet Food Pro. This series of expert chats is brought to you by Pet Food Forum and the editors of Pet Food Industry, the magazine and digital content provider with decades of providing the market with pet food expertise. You can find our content at petfoodindustry.com. Ask the Pet Food Pro offers a great opportunity to connect with pet food industry experts and ask the questions that are most on your mind. Today's chat is about the next generation of pet food processing technology, and it's supported by Bühler. Thanks very much to them. And our expert today is Jerome Usch, Business Development Manager of Digital and Value Nutrition for Bühler. Thank you for joining us. Welcome, Jerome.
I had to unmute myself there. Thank you very much for the invitation. Glad to be here. Hi, everyone.
Okay, so before we start on the discussion, just a few housekeeping notes. First of all, you've all been muted to ensure everyone can hear and focus on the discussion. So please submit your questions or comments in the chat box. Some of you submitted questions beforehand, and we really appreciate those, and we'll try to get to as many of them as we can before we adjourn for the day. And then finally, this chat is being recorded. You can access recording starting in about a week at petfoodforumevents.com and click on the Ask the Pro tab at the top. Okay, so let's just dive into it. So Jerome, the title of this chat includes the term Industry 4.0, and we also hear a lot about the Internet of Things. Are those interchangeable terms, and what exactly do they mean?
Yeah, so they're basically both buzzwords. There are some great reports from Gartner that are about like what is the next big thing in technology, where they would show the greatest buzzwords that there are. And these have been like high up there. So usually that's not a good sign for technology.
Right.
To be on that list, because that just means there is a huge hype train coming and at some point the technology will be dropped. But on the other hand, like after this first hype, and we've been gone over this for a very like, I think the first time I saw it, it was like 2015 and 16. So we are now in a consolidation phase where we actually see progress happening in like technology wise in our industry. And yes, so both terms are interchangeable. Where they stem from is basically with the third like industrial revolution being computers themselves and automation. Industry 4.0 is just the next step on the ladder, which just means decentralization and using cloud infrastructure to run local hardware. We are still far away from that, and there are also risks attached, but this is what it's supposed to mean. So interconnectivity of devices, they can talk to each other, things like that.
Okay, that makes a lot of sense. So what kind of changes does that bring to a production facility, and why should a company consider it?
So in the beginning, again, it was a lot of buzzwords. It was hard to understand what kind of services there are actually, and how this can improve. I think the first biggest step is visibility of data and how we are able to access that data. So when I started my journey with this company, I was still used to having to go to like an operating room, look at the screens there, and having to like push buttons basically from one central location. And the biggest thing that changes is just availability of data is now on your smartphone. And what I just figured out in this industry, and what I used to say is we are usually like just behind about 10 to 20 years what like consumer end devices can do. So basically when things like chat applications and whatever came about, it just takes us about 10 years to be able to apply something like similar in our industry. And this is exactly the same thing. So I can now look on my smartphone, I can take a look at my production data and I can have KPI information there. And I think this is the first great change. And after that, of course, companies now start investing and trying to use the processing power and capabilities of cloud infrastructure. First, by just, for example, analyzing huge amounts of data that come from your facilities. One example that comes into mind would be like a fault or warning analysis of your control system. And by understanding how often these errors occur, you can actually predict potential faults that will happen in future. So this is how people start now changing the way that we work. We get information before, or the idea would be that we get information before something happens. In maintenance terms, this would be, oh, your fan assembly is vibrating a lot. You should have it checked out by a mechanic tomorrow. And information like this can be very helpful in a production environment. So there are a lot of different places where this can get very like usable and helpful fast.
All the equipment get connected.
This is, I also saw already that there is a question that is also related to this. But so connecting the equipment is usually has to do with the partner that you choose for your journey. There are ways of how we would approach this. We have a safe and secure device that we put into a factory. That device runs under very strict IT security rules. And the idea is that this device then connects to sensors, equipment in your factory, and uploads that through a secure channel to a cloud solution. Now, one of the big problems is that not all equipment in IT terms talks the same language. So if we talk, for example, about programmable logic controllers, PLCs, they have certain protocols they use. So our hardware needs to be capable of understanding that protocol to be able to take that data and upload it. And these protocols also change depending on the vendor of the system, of your control system that you have. So for example, if you have a Rockwell control system, this will be Ethernet IP as a protocol. But if you had Siemens, it would be another protocol. If you have a computer in your factory, so let's say for example, one good example would be plant control systems usually have a PC attached to it. A PC is able to talk another level or is talking in another protocol language. So it's just, how do I connect my equipment? It all comes down to the protocols that your receiving unit is able to talk versus what kind of equipment you have in your factory.
Sounds pretty complicated. Right. It sounds very complicated, right?
Yeah, it kind of is, but that's like in the end, it actually isn't that complicated, because it just boils down to a few protocols that this equipment needs to be able to talk. And we on our end, we now came up with a solution that works pretty much like in every case. There is also things called protocol converters. So they do actually this work. They usually cost between $600 and $1,000. And they will convert any protocol. So there is, as you can see, there is already a market being established, because this is a well-known problem that everybody has to work around.
It's like one of the first steps a company should take is to talk to different vendors, different, possible suppliers about what they offer and the challenges that might come up in trying to connect all the equipment.
Yeah, I agree. First, they need to understand what equipment do they actually own that is able to talk in any language that like these vendors support. But usually if any vendor is contacted, they will usually send people on site, and then like in a workshop, you will basically work out the easiest way of doing this.
So there was a question about what technology exists that actually help a company profit from.
So with Industry 4.0, what people realized is there is a huge or there were already huge, or there has been huge research in machine learning. Machine learning isn't something that is new. Machine learning started like way earlier than the 2000s. The only problem was that we weren't applying it at scale, and most likely also because the knowledge wasn't around to apply it. And when I did my degree, this was actually just on the verge of changing. So the algorithms that are used for machine learning are, in most cases, fairly straightforward. They are not like rocket science anymore because they're very well documented. And this is this new technology that everybody's talking about. AI relies on machine learning. And if these algorithms are applied in the correct way, they can be used for all kinds of interesting things. And this is, I think, the biggest change that we're looking at right now. It's no longer basically inventing the wheel, it's reapplying what we already know. And by hiring somebody that is called, for example, a data scientist, this person has just been trained in applying certain algorithms because it's important to understand how they work, right? But this is what it in the end boils down to. What can we do with this? For one example would be by looking at how a dryer works over and over and over again, we can find certain patterns. Patterns are something that we humans would describe as, or we humans see those patterns. The easiest machine learning algorithms are simply algorithms that try to predict patterns as we humans understand them. If we talk about AI, this goes a bit out of the window. This is also, in my opinion, one of the biggest challenges with AI, because AI combines machine learning, multiple machine learning models behind each other, and this leads to a conclusion that is no longer understandable by humans. The conclusion might make sense, but there are also situations where the conclusion doesn't make any sense, and it's not possible for the human to still understand why the computer now came up with this. Whereas with machine learning, it's like I see a pattern, and this lets me conclude something. I think I digressed there a little bit, but what it all boils down to is I can have a machine learning model that understands how my, for example, dryer parameters work. Because I know if I have a certain temperature in the first dryer zone and a certain temperature in the second dryer zone, I understand that, like, I had this happen before, that my product got burnt from the outside. If I input this into a machine learning model, this would be, I could classify this as something I do not want to happen. And then combining good and bad situations, I will get a model where, for example, I can simulate what happens if I change my recipe parameters. And if I then gather enough data on the dryer and its environment, I can drive this as far as letting the machine basically control itself and try to find like an optimization for my current recipe, where I could say, the model's goal is to reduce gas consumption. but still keeping the product in a certain specification. And because it's all a mathematical model that allows you to basically reduce to this one best solution, this is something that we can then apply in our production. Sounds also very complicated, but there are trained people to do this.
Yeah, it does sound complicated, but you can also start to see the benefits and the strategy that companies can start to apply in improving their production and maybe even improving their products. Because they'll have all this data from the production side of what's happening and what's best to happen. So machine learning is a proven technology, obviously. Like you said, it's been around a long time. You did digress into AI, but because it is such a, it's on everyone's minds, on everyone's tongues these days. AI is less proven, right? We're kind of going through this evolution right now, revolution, if you will. So AI is applied to, say, pet food production is maybe not quite there. Is that a correct conclusion?
So I personally don't know yet of a case where it actually has been applied. The thing is also that such a model would be fairly huge, and it's always a question, what is the scope? What are we actually trying to achieve? So if I would talk about AI and a complete pet food production line, this would be like our final vision of what we are trying to achieve, like somewhere in the future. Like the goal that basically the plant runs on its own. But we are pretty far away from that today still, because it's much more challenging. And in the end, what it's going to be is, it's going to be, what I believe, a lot of machine learning models that run individual pieces of equipment. So trying to go from simple, like more simple things that we can optimize, and then as soon as your equipment, like every equipment piece on its own is optimized, you have then this umbrella where an AI model can try and control your factory. Because the first thing that you need to make sure is you need to have a stabilized production. And that's already, I mean, I don't have to tell this to anybody that runs a pet food production, but this is also not just a given thing. There is a lot of investment going into this. You need dedicated people that work day in and day out to make sure that you always stay in your production parameters. So this is like the first step, getting a self-controlled production line, and then we can start and try and optimize how the production actually takes place.
And with product development being such a big part of the industry, new products are always being introduced, which means new production parameters. So
yeah. So this starts over again. So every time you introduce a new product, you will run into troubles because maybe your equipment isn't matching it, like the new product characteristics 100%. You have to find workarounds. So this is hard. And also like an AI, for example, an AI model, this is something where I think this is also like what researchers are not sure about. Is AI creative? I personally don't think so. AI is just copying what it has already seen. While ChatGPT and these tools might seem like they're creative, what they're doing is they're just using a given, like a given set of information. And if you ask it a question, it will just return you the most averaged out answer that is possible. So again, it's a mathematical thing. It's not something that it just invented. It might sound new, but it's just the mean of everything. So there will also in future product development, there might be simulators that help you create something new because it gives you more insight into the product itself. However, the creative thought behind it will still be a human that comes up with something new.
Yeah, someone just posted a question. Can you see AI eventually becoming the standard operating procedure? And if so, in how much time do you think it would take that to happen?
I think that this could actually be possible at some point. The question is whether it's a question right now like value versus cost. Because if you were to do this today or try to do this, maybe you would even be able to get a plant to such a performance level. However, this is like a one-off solution. It just works for your specific case. You cannot reapply it. So it will be extremely costly for this one plant to do it. And like we would need to find a solution that is reapplicable for the whole industry to be able to use it. I think we can come to a very high degree of autonomy, but not fully autonomous, maybe.
And
And time-wise, I would say we still need 10 to 20 years for something like this. We can also talk about, in my opinion, the biggest challenges that we have today. I think the biggest challenge right now is capturing quality information. That's like the biggest challenge right now. We need like everything that we as a human would see as a quality indicator of a product, we need to be able to measure. And that's something we are not able to do today. And as long as this hasn't been resolved, we won't be able to do autonomous, like fully autonomous production facilities.
makes sense. And I think we had a question come in during registration about that. The question was, would the data collection allow for immediate correction of any errors detected? And really what that is speaking to is measuring quality, correct?
Yeah, it would be. I mean, it could also be other things. So for example, an immediate response would also be just talking out of something that I know that is very helpful is again like a vibration sensor on a device measuring higher than normal levels of vibration that are extraordinary. It should not be there. So this could like result directly in, for example, a text message sent to like the maintenance manager of the facility so that he can go and check out the situation. And then, of course, again, if you have for like live telemetry data, of course, this information can just be used and immediately fed back into the system. It really depends on what you're trying to do and what you're trying to achieve.
And I would assume it would depend on who's watching this data. You mentioned having data scientists. I mean, someone would have to be able to see what's coming in, the data that's coming in, and also analyze what that means, correct?
Yeah. Or you already know a given case that you want to monitor, and you are able to set up rules. If a threshold is reached, do something. And this is like, but this is also how like automation would work today. With PID loops, for example, this is like we try and level out certain signals that we get from machines so that they run more stably. And this will be exactly the same thing, just using a machine learning model, for example. So you know that certain parameters in your extruder will lead to good product. As soon as you leave that area of good parameters, and like a machine learning model could detect that your quality will be breached in a minute. This is just like linear extrapolation, because you can say, oh, quality is going down, and you could send a request to that machine, hey, for example, decrease water addition by 0.5%. maybe this resolves the problem. But that's what the machine learning model is then there for.
Any companies doing that right now? That level of Industry 4.0?
I had to lie if I said that I know like our whole competition. What I know is there is a lot going on in the predictive maintenance field. So basically figuring out that a piece of equipment is supposed to fail, including giving a time horizon until it will fail. That's something that is there for sure. I know that there are efforts of AI companies that try to control single pieces of equipment automatically. However, I don't know of any successful attempts in doing that. I also know that, for example, for extrusion, we as a company, we actually started with physical modeling of an extruder in, that was before the 2000s actually. And like mathematicians took a look at especially the extruder and they failed. They failed coming up with a model. But for example, for the dryer, there now exist models for good drying parameters. Of course, again, these are then, because I know that these are machine learning models, they only work in your specific use case. So they are again not reapplicable or not as easily reapplicable, whereas physical models are. But I also know that with dryers, physical models, for example, are possible.
Changing tactics a little bit. So you mentioned dedicated people, working on production lines, which, the pet food industry is fortunate to have a lot of dedicated, knowledgeable people. But we also hear a lot about how companies are struggling to find good people. Some of those people retire or decide to take a different path, and it's hard to bring in new people. So is Industry 4.0 machine learning, is that a solution or partial solution at least to the labor shortage problem in the industry, do you think?
I think it can partially be a solution. And not only by just reducing the amount of people that are required to run a plant. It also makes, in my opinion, the job more attractive. Just for example, being allowed to use the latest and coolest tools does improve the overall job profile. If I am able to check out my equipment that I run daily from home, as for example, somebody that manages production, this is also like a gain for me personally, just enjoying my job, what I do. Then we have like the whole like maintenance crew. There we can of course like we can try and increase the overall efficiency in how many people that you need to maintain your facility in an efficient manner. But these people won't go away. There will always be people needed that maintain your equipment. There will always be operators needed that can start up and work around troubles. It just leads to a future where, on one hand, we will need operators that might have a bit higher levels or like an increased level of education to understand how these models work, and they will have to reapply it, or they will have to be able to apply something like this. But that will come over time. So yes, like in operations, I think this will result in less people being needed for the same amount of equipment, but it will make the given jobs more attractive and it will make them more efficient. That's what I believe will happen.
Interesting. Changing tactics a little bit again, or changing the approach to the conversation a little bit again. So say a company or someone on this chat is looking to start, Industry 4.0, the interconnectedness of all their equipment. How do they organize themselves, their production facility to onboard that type of system? What does a project plan look like?
So what we would do is we would first have a workshop with all people involved, and that just doesn't just mean operations and maintenance, for example. So that also means including management. So basically every stakeholder that has anything to do with your production equipment today should sit on a table, and there should be an open discussion about all the big problems that you face today. Based on the outcome of that, you can weigh these problems by significance for the company. And this again would then be most likely a management decision. But it is very important, what I'm trying to say here is it is very important to focus on key areas that you want to improve. One thing that many companies, including us, did when this whole hype was about with machine learning and Industry 4.0 is, let's just start throwing money at things. Let's start collecting data of all equipment that there is. I mean, for us, it's a bit different because we basically develop pipelines that are used to transfer that information. We had to do that anyway because our customers would approach us and say, hey, I want to have this information in cloud XY. What is the interface? How do I use it? So that's a bit different, but what I also saw is that people were just trying to get data as fast as they could without having an actual plan what they were trying to improve. So first define KPIs that you want to improve, and then try and improve those KPIs and make those KPIs measurable. That's also very important because if you don't do that, you won't see your return on of investment. And of course, when weighing these problems that you try to work on, you also have then to get involved with machine learning, data science-based companies, because they know how easy certain problems can be resolved. So for example, if you just want to get rid of all those pieces of paper that are spread out in your whole factory and just digitalize this is a very easy problem, and this can be resolved fairly easily. Whereas if you come up to me and tell me, hey, I want this extruder to run autonomously, then we are going to have a really hard time and it's going to be very, very expensive. So taking all this into mind, the key is to focus on specific areas and try to improve these. This is also the strategy that we follow. So on one hand, we of course as a company, we try to engineer solutions for our customers based on that approach, but we try for every piece of equipment to find its biggest issues that it has, and then we try to resolve that issue, and also try to make this measurable, which is also why, for example, we now focus heavily on predictive maintenance, because unplanned downtime is still one of the biggest losses you can have.
Right.
So, and this is also what other companies, by the way, focus on. It's pretty straightforward. It's not that expensive. With a few strategically placed sensors, you can achieve quite a lot.
If you had to name, I mean, as you said, every company is going to have their own priorities and their own problems, but it sounds like predictive maintenance is maybe a core or a common challenge that every company might want to consider tackling with this technology.
Yeah, it is. Especially because also if you don't get involved with a company like ours or any other company, there are now fairly cheap tools available, for example, to just monitor your drives that you have on dryers, you name it. These sensors are no longer expensive. I even saw now there is, like this device has actually existed for quite some time. It just basically measures current over the 3 phases of your motors. And by doing so, it is able to measure vibration on the drive. You don't even have to put this on the drive itself. You can just put it into the cabinet where it is safe, where it doesn't get dirty, and you can use multiple of these devices to monitor all your drives that you have. So these devices will then give you an indication early on if something is about to go wrong, and you can replace the drive on time and don't have unplanned downtime. So these are, I would say, the easiest case of predictive maintenance. And then you get, of course, more specific with like equipment specific problems that you're trying to resolve. These are a bit more complex.
Right. Okay. We had a question come in beforehand about the use of process digital twins in the pet food industry and how extensive that is. Do you know, can you speak to that at all?
So maybe first, as an understanding what a digital twin is supposed to be, it's supposed to be a simulator that you can run online that acts as if you were standing in front of your machine and you were actually running product through that machine.
Ah, okay.
So it would, like, some companies have started calling digital twins just like if you have a picture of your machine online, that's not a digital twin. So it's more sophisticated than that. So the idea would be that you, for example, have a screen next to your machine where you are able to pre-apply certain changes that you want to do to your recipe. And then this simulator will tell you, yeah, the product will have, when it comes out of the machine, it will have this and this and this product characteristics. I know that there are companies out there that use something like this already, for example, on dryers. I cannot, of course, not say which companies these are, but what they use it as I just described. So if they change production parameters, they would first enter that information, for example, into such a simulator. And the simulator would then tell them go or like no go, basically, like whether what they're trying to do is possible. The digital twins have much bigger implications though, because it allows us to, if we have such a model, it allows us to pre-test basically all kinds of different scenarios, also in an automated way. So we could try and optimize our recipes without actually having to run those trials on an actual machine. Yeah, and I know that there are companies out there that already use that. It doesn't exist for an extruder yet. I know that it exists for dryers. Yeah, I think for other pieces of equipment, I think I haven't heard of it. But also, I think these are the two most complex pieces of equipment in the pet food industry. So yeah, the most relevant ones to this topic.
The path that you think it would be good for the industry to pursue or for companies behind the technology to pursue? I mean,
You mean creating digital twins? Oh yes.
Yes.
This is, I think, for every machine, if you have like a good digital twin, this is like, not really the holy grail, but it has a very high significance, because this would allow, for example, an AI to train without running, like usually what we like for machine learning, the algorithm has to be able to see the equipment in action or it needs real-time data. If we had simulators for all pieces of equipment that we know work well, we don't need to run our actual equipment to get like those dangerous cases, for example. If I want to train a machine learning model on how well a dryer works, I don't want to burn up my dryer multiple times just for the model to understand that this isn't a good idea.
Okay.
So if I have a model that is able to simulate this, this could save me a lot of time, but just by the nature of the simulator. So.
And a lot of equipment money, sounds like, too, equipment investment.
Yeah.
So
What I want to say is, and this is also an important takeaway, like generated data should never be used as an input for machine learning models. So this is the same thing. You might have heard of this fight for data in the internet. What basically happens is Microsoft, Facebook, Google, Amazon, they're fighting for real human-written information to be able to build their AI models. The same is the case in your production facility. If you run simulator data into a machine learning model, the outcome will not be good.
that makes sense,
And this,
right?
yeah. So what I meant by saying this is I'm not saying that we should use simulators to create these models, but these models can actually be used in a chain of an AI model to predict the outcome of your product.
That makes sense. That makes a lot of sense. Interesting. Well, if anyone has any questions, just a reminder to please put those in the chat box. Are there any areas about within this whole Industry 4.0, Internet of Things, that we haven't talked about yet, Jerome, that you were hoping to get across today, that you think it's important for people to know?
Let me think. One topic that we haven't touched on is information or IT security.
That's an important one. Yep.
Yeah. So where do I start with this? IT security, I mean, it's very important, like in any aspect of our lives, and especially if it is about your production data. So one thing that is first I should bring across is open source software versus closed source. And what we followed, like which strategy we followed as Bühler, is we are trying to rely, if we develop something that is used and that has like IT security relevance, by that I mean this piece of code touches information that our customers own, or that like information that we own that we don't want to be released publicly or to be stolen. We rely heavily on open source software just because we want to make sure that the software that we use is proven. There are advantages to closed source, which means nobody is able to see the code besides the owner of this program. With closed source software, you have the advantage that nobody knows how the software works, so it's maybe harder to attack, but it cannot be maintained by a community, and the community cannot try and find problems in that software. The second is you are going to need, if you develop something like this on your own, you're going to need partners. We chose Microsoft as our partner, but of course there are like the big four, which is like Microsoft, Google, Amazon, and Facebook. You're going to need one of those partners. They have huge cloud infrastructure, and for them, it's basically, if they would have an IT security breach, this would mean that the company would lose complete trust immediately. So for them, it's absolute key to have their software that you are also able to reuse, that is secure. One example would be authorization. How do I authorize somebody to access certain data? And we now just rely on, for example, what Microsoft hands to us. Microsoft has their own library for authorization. They manage the whole directory of like people with their respective like rights that have been given to them. So we don't even maintain that anymore. It's basically if a customer of ours uses a service, they use all Microsoft login and authorization. This will never, like all your information that you enter into these masks will never even reach us, which is very important for us because this also makes us not attractive for bad people to try and steal information because we never touch that personal information. So this is like an important topic. You need to make sure that like your pipelines are safe where data is transmitted. There are ways to ensure that. One to mention, for example, is direct VPN connections. So if you transfer data somewhere into the cloud, you can basically create a VPN tunnel directly from your piece of equipment to the cloud, so nobody can take a look at your data. There are public, of course, like encryption standards available to encrypt everything that you send. Yeah, but this is, of course, this is risky. You should involve your IT department early because they will most likely be first like, oh no, please, I don't want this. But sadly, the future will include a lot of digital, like PCs and them communicating. That's something that will only increase the way you like. And this is, I want to share this, and this is very counterintuitive. We are in like just from experience on how different companies treat IT security. For some weird reason, companies that have been hacked and like had this whole problem with reputation loss and everything are much more open to discuss connections from their equipment to the cloud, to any cloud, because they were forced in that situation when this happened. Their IT and the whole company itself was forced to embrace this problem of IT security. And budget-wise, they most likely don't invest that much more money today as they invested the days back. It was just like out of sight, out of mind. I don't want to deal with IT security. However, it's a better solution to actually embrace the problem that we have today and just not try to like prevent anything that could be bad, but try to understand the processes behind. And this is also the way to identify potential risk factors. And it's also important to mention that still today, not like your standard pipeline to the cloud is the risky factor. It's in 99% of cases where a data breach happens, it's operator error, or user error, not operator, it's user error. Plug in a USB drive that you find lying in front of the office is, I believe, still the best example. And I think all companies worldwide now have like measures in place to tell people, hey, please don't do this. This is a very bad idea. Like even deactivating USB ports on all devices for USB drives. By the way, also the case in our company. So we are not allowed to use USB drives. You need special allowance if you want to use a USB drive. But this is just like one example. In most cases, it happens through phishing attacks. So this is what I would suggest is to invest money. There are companies out there that actually sell this as a service, basically courses for your employees. I'm not going to give you a name here, but we have an add-in in Outlook that sends you phishing emails once and so often. And it's basically a game, and you have to figure out when you receive one that it actually is one. And they are getting extremely good at basically mimicking. It's really hard to find those phishing emails, but it's like this game allows people to be much more cautious about what they do.
I know Bueller is a very large company. Our company is pretty small, and we have all that. We have cybersecurity training, and we have trick emails, phishing emails come in to test our knowledge and our practices. So yeah, it's a very smart thing to do these days.
Yeah.
So yeah. Okay. That's not a turn I expected to take, but it's very interesting. And I think you're right. It's very important. Anything else before we wrap up today's conversation?
If there aren't any more questions, nothing from my side.
Okay, well, thank you very much for Jerome for the discussion today and for sharing your expertise. I thought it was very interesting and hopefully gives everyone on the call a glimpse into the future and what might be possible for your production facilities. Thanks again to Bueller for their support for today. To continue your learning on pet food processing or other industry topics, please watch for more of these Ask the Pet Food Pro chats coming in 2024. And we also have a lot of webinars we do that you can find on petfoodindustry.com. I also give a shameless plug for our Pet Food Forum conference coming up in late April. Registration is open for that. We really would appreciate your feedback on today's chat. So if you could please use the QR code on the screen, or you will also be getting an email with a link to that survey. We would appreciate your feedback. And finally, just a reminder that this has been recorded, and the recording will be available in about a week on petfoodforumevents.com under the Ask the Pro tab. So thank you again for joining us today. Thank you again to Jerome, and I hope everyone enjoys the rest of their day or evening.
Thank you also from my side. If you want to chat, I'm pretty surely going to attend Pet Food Forum next year, so please come by our booth and say hi.
Okay, good to know. Thank you.